Hi, I'm Raymond Monroe with the Steel Founders Society. Most of you know me. This is our first effort to do a podcast because one of the challenges we face is how do we capture all the things that are in the heads of all the people late in their career like me and get them in a way that you can enjoy learning them, understanding them, without trying to really write textbooks or encyclopedias. And so this is our first podcast. I got two of my dear friends who've been friends for a long, long time, Ed Kesmerick, who ran Spokane Steel, and of course, Peter Mackler, who's designed most of the steel foundries. And my intent was we would talk about capital investment and how you make those decisions. And I started out with the introduction talking about quench tanks, and we spent the whole time talking about how you think about production processes and equipment in the foundry. And so I hope you find this to be a really interesting podcast, and I look forward to doing more podcasts in the future, both with Ed and Peter, and then anyone else who you think might be valuable. So listen, enjoy, give us feedback, give us new questions, suggest people for us to do podcasts with. Thank you. I think the challenge for us is we really want to help the next generation of people, and we've got a lot of stuff in our head, and there's no good forum to just extract it and get it to people. I mean, we could, in 100 years ago, collaborate on a book on steel casting investment technology, but that would be a huge effort on our part. But having a casual conversation, and one of the reasons that I wanted to do this is Peter and Paul Rudd and I were at the POK opening, and we're there next to the quench tank talking to the quenching guy, and Paul and I are telling him, yeah, you really have to get it in the water in less than a minute, and you really need to control the temperature of the water. How's your cooling tower working here? And then Peter pipes up and says, well, you know, obviously you need at least 1.5 gallons per pound, and 3 is sort of an upper limit, but 2.5 is really sort of the sweet spot for quenching. And you need 4 horsepower for every 1,000 gallons. And you go, wow, I didn't know that. And those are the kinds of things I want to do. And so last time Peter and I were together, I was saying, you know, we have a bad habit of buying the largest, a heat treat furnace is large enough for the biggest casting we ever think we're going to make. And then we batch things so that we let casting sit around for 3 or 4 days waiting to get enough to make a full heat treat load. And Peter tells me, oh, that's a dumb idea. You should buy a smaller furnace and get out of that big casting business.
Right, exactly. I've seen that in other foundries where the whole thing shuts down because of one set of castings being out of the sweet spot of the foundry, and that the whole foundry suffers. Get rid of that work. You don't need it. It disrupts the entire operation.
Yeah, and I think those are the kind of things we want.
Just building on that as an example of this potential podcast give and take, one of my struggles has been that systems get designed for the largest possible item or larger item, and then you figure out like how to get multiple on. So we're going to make this big casting that requires a mold of X size. And we'll probably make, maybe 10 or 15 of them this year. And in the meantime, we're going to get this other job and we're going to have to put it 18 on so that we can utilize the plate size of the mold. So I don't know if that's where Peter was going with that, or if that's an offshoot, or if you would disagree with that big part of the
I agree that if you assume there's only one plate size that can be used, that's very true. But my assumption would be we can have multiple plate sizes. I mean, we could, in the case of air set mold, we could use flaskless instead of flasks. And I've put together some pretty big flaskless molds. And there you're not limited. You can make a small mold or a big mold and be optimal. But the problem is processing the big one. Will it go through and hold everything else up? That was the case that I ran into, where the whole line was shut down because of one big mold. Had to sit on the line to cool for 16 hours, and all these others could cool for an hour and be shaken out. So suddenly everything's backed up for 16 hours. That was not logical. So get rid of that job altogether and then do everything that runs sweetly along in 1 or 2 hours.
So Peter, that raises two really interesting questions to me. One of them was, when one of my members that makes lots and lots of castings for Caterpillar, big stuff, little stuff, bought an automated line from IMF. IMF asked for the distribution of casting sizes so that they could size the equipment appropriately. And so that you could handle the largest one, but that it was efficient for the smaller stuff. And it turned out, of course, that IMF's equipment design failed to recognize that when I'm making the largest casting I make, I'm making it all day.
Right.
So it was destroying the equipment, even though the equipment was designed to handle that once or twice. Have you run into that before, that kind of problem, where when I'm making the big casting, I'm making them all day long? So I really would have to have a capital plant that can handle the largest casting production.
I would take that offline and have a separate mixer for it. If it's only one a day, you don't need automation. You don't need automatic rollover draw. I would take that offline and make it in the simplest possible form. The rest of the smaller casting can run through the automation and not be stopped.
Yeah, so I haven't been clear. The challenge is that the day I decide to make the large casting, I make 10 of them on the line. And so I'm really beating the equipment up because it can handle one a day. But when I'm making 10 in a row or 20 in a row, I just beat the equipment to death.
Well, now you open up the infamous scheduling question. You know, why do you need to make them all at one time? If you need an average of one a day, do you just run that at the end of the line, so it solves the question about the 18 hours of cooling time? You let it sit, and it takes care of the issue of beating your equipment up. But it does require, or immediately implements, a production scheduling milepost that you have to allow for that.
So you were using that equipment though, Ed. How easy would it have been to change out the pattern and still keep the production rate?
Well, with the more modern equipment, that's really not that big of an issue.
Okay.
It becomes a bigger issue if you start to come up with lots and lots of exceptions. And then you better have somebody darn good running your production control department.
So
There's another aspect to this. If you run 10 in a row of these big castings, you're probably not going to have the melting capacity to do it. And if you design your melting shop to do 10 in a row, it'll probably be used 10% of the time throughout the year because it'll be grossly oversized. So the notion of trying to run 10 big molds in one day, you'd have to have a horrendously large melting shop, which wouldn't blend or fit with the nature of the rest of the work. So that should not happen. I mean, scheduling is always important, but you can't do what you said unless you have a monstrous melt shop and a huge cooling floor to put a lot of these things out. I mean, I've got, as you know, many customers doing the big work will have molds on the floor 4 or 5 days.
Sure.
And you've got to have provisions for the space for that.
Yeah, one of the things that Charlie pointed out to me, and we wrote a paper on the fact that you generally underprice the largest casting you make because you have a fixed capital, fixed rate for the basic overhead, And if you're not really in the business of making that large casting, the capital element that you're charging people is too small. So the smart customers know if they buy the biggest casting you make, if they went to somebody who makes that casting every day, they get charged more because they have a larger capital investment that they have to liquidate.
Well, that gets back to ABC, activity-based costing and accounting, which I'm a strong advocate. You need to know what your individual costs are in every aspect of the business. You cannot use a peanut butter overhead system where you spread it over evenly with no idea whether it belongs on that piece of equipment or not. I see that all the time. They need an activities-based costing system to really understand that.
It's really a challenge of the activity-based costing, because whenever I ask people, they're all deeply committed to doing it and completely incapable of doing it because they don't have any way of getting that information. And so as soon as I go to really high mix, low volume stuff, I can sort of aggregate buckets to try and get at some activity-based costing.
I'll buy that. If you have similar castings, similar alloys, similar sizes, similar production methods, that's perfectly adequate. And it makes it quite a lot easier for those customers. It doesn't have to be per part number. If this part numbers are extremely similar, make it a group, put it in the bucket. I think that's a good idea.
So did you ever work with anybody that used the sort of citation method where they had like 5 or 6 barriers for cost? And so they used whichever one gave them the highest price. And so they had a minimum per square inch of parting line. They had a minimum per heat. They had a minimum per heat treat load. Did you ever work with somebody that used that? And what did you think of that as a way of getting at costs?
I have not worked with it, but it sounds like it's better than the peanut butter system.
I wanted to come back when you were talking about cooling. One of the things that I've observed is we pretend that the cooling cycle is not part of the production when we design the plant and organize a plant. So when we have large castings or we have too much production for being inside, we just put them outside, let them sit out there for a week and bring them in. Is that a perennial problem in foundries, or do most foundries think about the cooling rate and have plenty of space inside to hold them?
I'd like to think that the more modern foundries do take that into consideration. You've got a couple of other aspects. EPA doesn't exactly appreciate they're taking processed materials out in the rain because of the stormwater runoff. So, and then people do this, be it the sand or the castings, it's a processed material that goes outside, and that's not permitted unless you have it covered and you prevent water from running through that area. I mean, all of that's covered under EPA. So that process, I think, will come to an end sooner or later because of EPA, unless you have a building or a shed outside that's properly protected from rain and runoff.
So if I'm
one of the issues
castings and you're designing my plant and you want to make sure I have adequate cooling time, what's your 2.5 gallon per pound rule of thumb for how much time I need for each mold to sit before I can process it?
Well, that's going to depend on the alloys, because some of them will shatter very quickly if they're exposed to cold air, and others will not. So that'll depend on the alloy you're pouring. Certainly the temperature of the casting in the mold when you open it up, and the alloy you're pouring. I'd have to go to reference books because I don't pack all that away as to which specifically you do, but I just know from working in some very large foundries, you should have the capability, if you're going to make those castings, of at least some place where you can store a mold indoors from 3 to 5 days. And I suppose if you went into the old days when they were pouring 200-ton castings, You might need 2 weeks or 3 weeks. I don't know.
Sure. So Ed, you had to deal with the full range of alloys. I assume that if it's carbon steel, as soon as it's solid, you don't give a rip. You could, as long as you don't smash it and bend it or do something stupid to it. But the chrome irons, of course, you want them to get dead cold or shake them out hot enough that you can put them in a furnace. So what did you do in terms of understanding how long that thing has to sit around?
Well, what a perfect setup question. I want to backtrack to talk about things change. So
Sure.
it's one thing if you build a new facility and you've got a product list and here's what we're going to run on it. But I suspect that most of the Steel Foundry Society members aren't building new foundries on a regular basis, and they're dealing with legacy equipment that then gets tweaked over time and the product mix changes. And so just as one example of how it's not that simple, say you stick with your idea of steel, you can shake it out hot, who cares, as long as you don't bend it in some gross material handling way. It doesn't really matter. Well, nice try. But if the system is set up for sand returning below a certain temperature and you shake it out hotter, then you run into big problems with your sand handling system and the return sand system. And so you become constrained on how hot can you shake out the steel casting, not by the metal temperature, but the sand temperature coming back through the return sand system becomes a constraint.
Okay. Huh. I assume
It's that darn theory versus, reality kind of thing.
Sure. Is that mainly a green sand processing question, or is that something that you had to deal with your chemically bonded sands as well?
Well, in the particular company and product mix you're talking about, that was in chemically bonded.
Okay. That's interesting, because of course the green sand people always whine about hot sand, both from the temperature outside and the production rates. They're constantly facing that challenge. So I just was curious about that.
No, it was a great question, and it opened up some other avenues there.
Oh, sure. I wonder if there's, in terms of pouring, do you try to have a variation of heat to heat chemistry, but then you've got the contamination from one heat to the next? And of course, one of the things that we do badly is treat, especially in an induction shop, we treat the furnace like it's a toaster. Oh, you want a piece of toast? Let's turn the furnace on and make a heat, instead of actually scheduling them. So once the furnace is hot, we're efficiently melting. And that's a 30 or 40% energy hit every time you turn the furnace on from a dead cold to get it up to temperature. So how did you schedule heats, arc furnace or induction, Ed?
Could I add something there?
Oh, please do.
I had a client that was a pump manufacturer, a small one, so you probably don't know it, but they had, I believe it was a 3-ton arc furnace. I haven't seen many that small. They would start on Monday melting the lowest alloy metal they were going to melt for the week, which was kind of a mild steel. And then they work up through gray, ductile, and then they'd hit the high chrome on the last day. And then they'd scalp out the furnace over the weekend and start the next week. So, I mean, they did that like clockwork. They knew exactly what they had to do. And that was just, I know it's simplistic and it probably wouldn't work for everyone, but in their case, it was very satisfactory.
scheduling becomes an issue there, and that's kind of
It
why I
is.
was
It is.
kind of trying to think of, okay, what aspect do we want to grab this by?
Well, apparently it was not a problem for them, and they had gotten so used to it over many years, it was just natural. I know that might be odd to some. They say, well, don't let the furnace drive the process. In their case, it did.
Well, some people have a greater challenge. So one of the strategies you might use if you make cast iron, steel, and stainless steel is that the stainless steel and cast iron are basically incompatible. In cast iron, you have high carbon, low, and you need low chrome. And in stainless steel, you got all chrome and no carbon. So you've got to isolate those. But in the induction shops, one of the things they'll ordinarily do is they try to avoid wash heats. And a wash heat is when you just melt metal to clean out the furnace. And so what you try to do is schedule so that you might have cast iron to begin with, and then you'll make a couple of heats of carbon steel to wash out the furnace to get the residuals out of it, because it's not going to care if you can use low enough carbon material and the carbon content can go up, and you can at least try to manage it that way. And then once you've got all of that out, you can move over and melt the stainless steel. And sometimes in stainless steel, they'll have a wash heat, but it won't really be a wash heat. They'll just take all the crappy stainless that they've got laying out in the yard and make some heat treating trays for internal use, so that they can use up stuff that's too high in carbon, has other contaminants in it that make it difficult to use in an engineered product, but it's still got the basic alloy content in it. So they'll use it in something like a heat treatment fixtures for themselves. They might even have a heat treater in town that they could also sell it to.
I don't see that often. You've probably been in more foundries than I have, Ray, but I've been in probably close to 1,000 in 42 countries. And I rarely see a single furnace doing all that. There's going to be multiple, particularly induction furnaces, because they're not all that expensive to pop in there. And you're going to have shops, there's going to be our gray, this is our stainless, they've got a separate furnace. I mean, I rarely see them using a single multi-purpose furnace. I mean, that is really odd. And from my point of view, now maybe with the arc, yes, they do, because you got a bigger problem there. But with the smaller induction furnace, you can buy a 1,000-pounder for that and 2,000-pounder for this, no big deal. And
I think you're right about that. I mean, you've probably been in more foundries than I have, by the way, but having said that,
I don't know.
You're probably right. That's probably sort of residual memory from like 20 years ago, when people had only one or two furnaces. And you're absolutely correct. When I go into a induction shop now, they'll say that's the iron furnace and that's the bronze furnace. And yeah, I think that's correct. One of the things you remarked when we were together last, which I thought was really helpful, I asked you the question of justifying putting in an induction furnace when I have an arc furnace shop, so that I have 1,000 or 2,000 pound furnace to make prototype parts and first articles and that kind of thing. And you indicated that that's a trivial decision, because anybody would be stupid not to do that.
I didn't use the word stupid, did I? Well, look, I have very good friends and owners of steel foundries that have arc furnaces, and some have arcs and induction, some are purely induction. We can arm wrestle that all day long. There's 1,000 reasons that they all come up with for their justification. I say, what are your melt losses? If you're melting something cheap, then you can afford a 10% melt loss. If you can't afford a 10% melt loss, you want a 1% melt loss, go in induction. If you want 600 horsepower of dust collector on the arc furnace, have at it. If you want 60 horsepower on the induction furnace, have at it. I can go down the list if you want. But it's a hard case to make today if you include the dust collection and all those facets, And EPA is making all these products, off products of arc furnaces, hazardous material. Slag, dust collection dust, they're making all these things hazardous. In California, you pay $300 to $500 a ton to get rid of it.
Wow.
I mean, there's no case that you can make for the arc furnace except where you got lousy scrap. You can take lousy scrap, put it in an arc furnace, you can make good iron and steel. You can't do that in an induction furnace. What you put in is what you get out. So the only big justification for arc, in my view, is if you got crappy scrap and use it.
Well, let me push back on that just a minute, because
I'm sure you will. I thought I bait you into this.
Yeah, you did. I have routinely proposed that if you're making less than a ton an hour, induction's your only option.
Fair.
If you're making more than 10 tons an hour, or you're making castings of way more than 10 tons, an arc furnace is probably what you need if you have any volume of production. You're absolutely correct that I have members that have moved from arc furnaces into larger and larger induction furnaces. But unlike the iron people who have very large induction furnaces, most steel foundries might have a 3-ton, maybe even a 5-ton induction furnace, but that's about the biggest ones I've seen. Maybe you've seen bigger ones. I know that Voest Alpine put in a 60-ton induction furnace over in Lentz.
Well, here's my take on that. The biggest steel foundry I ever had a partake in was a steel mill.
Yes.
And it was a mini mill, except that they put 6 50-ton induction furnaces in. So I went back to EPA to get the air permit. I said, this is not a mini mill, because EPA specifically says a mini mill has arc furnaces.
Correct.
And I said, this is a very, very large steel foundry. And guess what? I won.
Oh, yes.
These 2 steel mills that I got permitted with state permits, not federal Title V's, are now, when they finish building them, of course, very, very large steel foundries, the biggest in the world, I suspect, because steel foundries. And that was all because of the difference in the pollution and all the other aspects of EPA that the induction furnace did not create. So, and I get phone calls from all over the world because they heard Mackler was the first engineer to ever get a state permit for a quote, quasi mini mill, or really a large steel foundry making ingots or making whatever. So I think a lot of this arc furnace is tradition and folklore and all that. These people have been in it all their lives. That's what they know, and they're going to stay there.
Yeah.
The truth of the matter is, it's moving very quickly toward induction melting, my friend, because of EPA, if nothing else.
Right. Yeah. I would broadly agree that the future is moving in that direction. Where I have a little bit of discomfort with that is that you still have to have a substantial amount of money to do it.
Right.
And so you're dealing with, call them monuments, legacy systems, whatever.
Exactly.
The reality is that there's going to be a lot of steel foundries who are going to have arc furnaces, and they may love to convert to induction. It may even be a good long-term capital dollar or long-term financial return to make that conversion. But they still have to have the capital dollars up front to put it in.
Understood.
I think that's right, Ed. And I mean, you ran you were there at the foundry in Milwaukee that had both induction and arc melting. And then, of course, later in your career, you went in an arc furnace facility that thought about getting an induction furnace regularly and never spent the money. So you've agonized.
Well, there was an induction furnace there for investment cast.
Yes, yes, yeah, and so 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 you're saying that, and I think this is correct, that you end up with a legacy. I tell people even today that if somebody in a steel foundry says they're going to use the new furnace, it was probably installed before 1980.
How about 1928? I've got a few about it. Yeah,
And
very much
also,
legacy.
and also, going back to talking about looking into the future, what can be used now. It's just the circumstances have changed around this equipment. And so it's one thing if somebody's focused just on melting and they're making the case on melting. It's another thing to recognize that the quality of our scrap in general has improved and that the regulatory requirements have tightened up. And so it's not just a question of what is somebody comfortable melting in, what is their expertise, what's their past experience. If you're moving into the future, you say, yep, I recognize all that, but we're moving into the future and this is where the future is. And the future, largely speaking, is induction if you get the money.
Yeah, and one of the interesting things, a couple of observations. One is the DOE continuously has tried to make melting furnaces more energy efficient. And they're under the MBA financial notion that if I can if I can increase the energy efficiency by 10 or 15%, then people will make their existing equipment obsolete and install a new furnace. And I have to tell them, look, we're not going to do that but once every 30 years at a maximum. And so you really don't have that opportunity. But the fun part is to tell them, look, in a steel foundry, the energy cost is somewhere between 5 and 10% of the cost of the product. And it's worse than that. It's not only not very significant in total. When energy prices are high, I can put my full profit on the total cost of energy and the customers are delighted to pay it. And when energy prices are really low, I don't care anymore. There's not enough money on the table. So if you have an incentive that buys me new lighting in the plant and you've driven my capital costs so low, I'm happy to do that to upgrade the plant. But if you're just trying to get me to make an energy efficiency investment, I have to, and this will preface our next discussion next time we get together on capital and capital equipment. If you look at it, I don't have the capital money to do it. And so my position's always been when I look at my capital investment for next year, number one, I have to do all the regulatory compliance or they just put me out of business.
Right.
Number two is I have to look at my market space and see where I need to invest to replace markets that are going out of business or supplement my capability in machining or something else to stay in the markets I'm currently in. So I have to protect my markets, number one, because if I don't have anything to sell, if I can't sell anything, I'm out of business. And then if I have any money left over, I'm going to try and reduce the labor content because that's the most difficult challenge I have even before the workforce issue. And so when I get done with all of that, energy efficiency never can really make the cut in terms of just a pure economic decision.
Yeah,
What do you think?
I don't know what
reasonable.
10% of your, just say it was 10% of your cost is energy and you save 1%, or you save 10% of 10%, that's what, 1%?
Right.
I mean, that might buy some lights for the building, but it's certainly not going to buy you a melting system. I agree.
Yeah, right. I don't know what, and this applies to a lot of, when I listen to discussions about converting the current efforts to electrify everything. But I don't know what Peter sees in other countries, but I've seen and talked with people where their government will directly subsidize them to make that energy leap, if you will. to convert from X melting system to Z melting system that'll be more energy efficient or environmentally benign.
Mhm.
And they'll pay for that directly. And so you say, why would you, how could you ever do it? Why would you ever do it? Well, there's one way it gets done.
Right.
Yeah, and I think that's right. And one of the things that we're understaffed here, if I could find two people that were bright to do energy stuff, I would try to aggregate. For example, for arc furnaces, I could aggregate 10 foundries that would take $2 million a pop and have a $20 million request for capital money from the Department of Energy to further electrification and reduce the carbon footprint. I could do that if I had the people, because they're going to spend $1 billion a year for the next 5 to 7 years trying to electrify us. I had thought about trying to do that just in printed molds. That's going to cost you $1.5 million. So that if I got 10 or 12 foundries that were interested in that and aggregated, they don't want any proposals that are less than about 10 to $15 million. So we'd have to look at aggregating that demand to do it. And we may end up doing that. So to me, the whole energy climate thing is always going to be an undifferentiated benefit to the steel casting industry, whether we try to do climate change and fail, or we decide not to do it and we need to increase the amount of fossil fuel, or if we decide to go nuclear. Any of those futures means you need a lot of steel castings. This has been great. I think this will be really an interesting podcast for people looking at it. I'll put an introduction in front of it and a conclusion behind it. I don't know if you had any observations or things you wanted to bring up, but I think this has been really an interesting discussion.
There's one sentence I'd like you to remove from what I said.
Yeah.
When I referred to arc furnaces, I said the only case I'd use it, strike that out of there, because I'm going to upset my friends in Canada.
Okay.
So I don't want to rile them up too badly. I think there's enough material we can put in there regarding
there's more than enough.
And dust collection costs and all that. Yeah.
He'll edit that out. And when he gives you the first cut edit, we're happy to take out anything you're uncomfortable with. Yeah.
I'll take a look at it, see how it floats. I just, I'm expressing my unedited thoughts, and that's what they are.
Yeah. Oh, and we want that. We do want that, because I mean the value of a podcast is all the different rabbit trails we went down that I never would have thought that we were going to talk about. It all was valuable information that we want to share with somebody, because we know that that's something that people would find of some value. So I thought it was really, really useful. Hope that you enjoyed doing it. I enjoyed this. You're both people that I hold in the highest regard. I think both of you have the same brain defect I have, that you can't stop thinking. You can decide what to think about, but you can't decide not to think. And so I mean, there's only a few people I know that I can ask them any question about what goes on in a steel foundry, and they've given it some thought. It's just not, we've always done it this way. They've thought, well, why do we do it that way? So that's,
I'm not sure that's always such a good thing, but yeah, it's probably true. Yeah, we just have to be able to have a discussion like I think we did, and recognize that sometimes we might have more disagreement than what we had in this go around.
Oh, absolutely.
It's all done in good faith, and people come at things from different angles, and you have some different personal experiences that you're building off of, and that's fine. You get those. I think what we're trying to do is come up with some different perspectives and give people some stuff so they get up the curve a little bit faster.
And one of the things that I would suggest we may want to do is we may want to invite one other guest when we want to dig into something in particular. So if we wanted to talk about high performance steels, we might want to get Paul Rudd to join us so that we could talk with him as well. And that would be interesting. So if you think of somebody you'd like us to talk to, I'd be happy to invite them, because to me, what I'm trying to do is allow us to have the conversations and let the next generation of people look over our shoulders and say, those guys were stupid. I don't know why they said that. And at least they'll be amused.
Maybe when you put out whatever you have, or as time goes by and this becomes a little more regular, presumably, whether it's this group or some other group, and you just say, hey, if you have questions, or there was a topic that wasn't pursued as far as you would have liked it, submit a question, and then maybe have some follow-up either at the beginning of the next one or somewhere along the way. You say, hey, we've gotten these questions in, and sure, we'd love to clarify some of it. If one person had that question, probably lots of people had it, they just didn't ask.
I think that's correct. And so I'm going to get Rob to put a comments and questions section in so that we can capture those, and we may want to just revisit them at the first of the next one or something. But oftentimes they'll open up a whole nother avenue to talk about. And that's, I think, really useful. And so I know I've enjoyed talking to both of you individually for years and years and years. I'll probably introduce you as old friends in every sense of the word.
I would be. Although I'll say, if you guys are knocking on 1,000 foundries, I thought I was doing pretty good to be over 100, but I'm not anywhere near.
I've worked in about 250 in 20 countries, so I've actually done boots on the ground in about 250 in 20 countries. So,
wow,
I've actually been in more iron foundries than steel foundries, and quite a few of the very highest volume iron foundries.
That's a really different background that you have, and of course I touched on it when I was with Saturn for almost a year, and so I at least understand some of the language of making a part every 15 seconds and how that changes your world.
So anyway, I don't know where this will go in terms of people being interested in it, but I enjoyed the discussion. So
I did too, and so let me go ahead and see if we can't turn this thing around and let you look at it, and then we'll schedule another one in maybe a couple of weeks and get together and chat again.
Okay,
sounds good, Ray.
Is this a good time for you? I put it at 10 o'clock so we didn't have to wake Ed up too early.
Yeah, I'm usually up quite a bit earlier. It's just I never quite know for sure. I'm in the Pacific time zone.
Okay.
So I'm usually up early, but yeah, I mean this time is safe for sure. But if there was a reason, I could start even a couple hours earlier. Probably wouldn't make any difference.
Okay. Sounds great, Ed. Thank you, Peter. Thanks, Ed. This has been terrific. Appreciate it.
Okay.
Thank you.
Ray, Ed, thank you very much.
Oh, you're quite welcome. This concludes this podcast. I enjoyed it. We had great fun. We enjoyed one another. I would intend for us to try and do that, this kind of podcast on at least a monthly basis, maybe even more frequently. And I'm looking forward to spending a lot of time with Peter and Ed. As you can see, they're really knowledgeable and capable. And so they were great friends to spend a little time with. I look forward to spending time with them and spending time with you in the future. So thank you for your attention. Bye.